Unveiling the mysteries of neutron stars. Welcome to our video exploration of one of the most fascinating phenomena in the universe. Neutron stars. In this video, we will dive into the captivating world of these celestial bodies, unveiling their incredible properties and shedding light on the mysteries that surround them. Join us on this cosmic journey as we unravel the secrets of neutron stars. The stellar remnants. Neutron stars are the remnants of massive stars that have reached the end of their life cycle in a spectacular explosion called a supernova. Unlike their progenitor stars, neutron stars are incredibly dense and compact, packing the mass of about 1.4 times that of our Sun into a sphere with a diameter of approximately 12 miles, 20 kilometers. Imagine squeezing an entire mountain into a sugar cube. The density marvel. The density of neutron stars is mind-boggling. In fact, their core density is so extreme that it challenges the limits of our understanding of matter. A single teaspoon of neutron star material would weigh around 1 billion tons on Earth. This unimaginable density arises from the collapse of the star's core during the supernova, where protons and electrons combine to form neutrons, resulting in a dense soup of neutrons known as neutronium. Gravity-defying. The gravitational pull near the surface of a neutron star is truly astonishing. With a gravitational force about 2 billion times stronger than Earth's, these stellar objects bend spacetime in profound ways. This extreme gravity causes a phenomenon called time dilation, where time runs slower near the surface of the neutron star compared to the distant universe. It's like stepping into a cosmic time warp. Pulsars. Lighthouses of the cosmos, neutron stars with highly focused beams of radiation are known as pulsars. These spinning cosmic lighthouses emit beams of electromagnetic radiation that sweep across the cosmos, creating regular pulses of light. Pulsars can rotate hundreds of times per second, and their precise timing has been instrumental in discovering gravitational waves, confirming Einstein's theory of general relativity, and uncovering the existence of exoplanets. Neutron star collisions. Occasionally, neutron stars and binary systems spiral toward each other, culminating in a cataclysmic collision known as a kilonova. These collisions release an enormous amount of energy, creating ripples in spacetime called gravitational waves. The detection of gravitational waves from neutron star mergers has revolutionized our understanding of the universe, providing valuable insights into the origins of heavy elements and the nature of gravity itself. Thanks for watching the video. For more videos, don't forget to subscribe.